Good morning and welcome to Sunday of week 5 of your Physics 5 a day. We've got practice questions on astro, quantum and waves today. Just before we start the first question, note that if you are doing OCR, we don't use the term flux, so we would call this intensity of light. Okay, and what we know about intensity is that it's equal to power per unit area. So we're talking about stars, so you imagine your star, it's radiating energy in the centre, and then the wavefronts are spherical, coming out in all directions. So the power is being spread out over the surface area of a sphere, and that means that we can write this. The surface area of a sphere is 4 pi r squared. Now, here's the star, the wavefronts are coming out. So when they reach us, it's like we're sat on the surface of that sphere, and so r is the distance from us to the star, something like this. Okay, and we know that the two stars are identical, and that means that their powers are the same. But star X has 4 times the flux, or 4 times the intensity of light from star Y. I'm going to stick with I's because that's what I'm used to. So the intensity from X is 4 times the intensity from Y. Okay, if the powers are the same, then we've also obviously got 4 and pi, they're not changing. And so that means that for our two stars, their intensity is directly proportional to 1 over r squared. And if the intensity of X is 4 times the intensity of Y, that means that its R needs to be half the size. And R for the star X being half the size means that R for the star Y is twice as big, and so that means we're on C there.